Lesson 63, 10.5, midpoint and distance formula. You're going to use the different formulas of a midpoint and distance to find midpoints and distances. The midpoint basically is the distance between the two endpoints. So it is the equal distance from endpoint to endpoint, and it is in the middle. Here's your equation. You have your x1, x2, y1, y2. Well, it's just like your ordered pair. You have your x1, y1 value, your x2, y2 value. Kind of like when you found slope, you set this up to help you find slope using the slope formula. The midpoint, so our x1 value right here would be -1. Our x2 value would be 3. We need to add those together and divide it by 2. So you'd have -1 plus 3 divided by 2. Our y1 value is -2, and our y2 value is -4. Add those two together, so we have -2 plus -4 divided by 2. We'd wind up with 2 divided by 2 and -6 divided by 2. When we go ahead and divide that out, we find out that our x value, this first value right here, is dealing with x's, so it's going to be your x value, which is 2 divided by 2 is 1, and -6 divided by 2 is -3. This is your line segment here. I basically plotted the 2 points and drew my segment. You're finding that midpoint, which is right here. If you look at it, and I were to actually plot this as well, you would have what we just found. It is 1, -3. So there's my midpoint right there of that line segment. When you jump down here, it's something you probably wouldn't want to graph. Look at how you have -17 here. That's why that formula comes in handy. So in example 2, I'm going to go ahead and work through example 2. I'm going to actually let you work through example 2. This is your x1 value, y1, x2, y2. It helps to put those headers on there so you can easily plug it into your midpoint formula. So go ahead, pause the video, give it a shot, work through it, and we'll see how we do. All right, now that you're back, we can go ahead and look at our work here. The first value, our x1 value is 3, our x2 value is 2, divided by 2, x1 value -17, or sorry, y1 value -17, your y2 value is -8, and that is divisible by 2. You have 5 halves, and you have -25 halves. I will let you know, since you're talking midpoints and distances, it's much easier to think of a distance in a decimal format versus in fraction form. So I like to have my midpoint and my distances that you'll be working with today in decimal form. So 5 halves is really 2.5, and -25 halves is -12.5. The answers will be displayed as a decimal, so it might be easier for you to have it as a decimal as well. In example 3, you're kind of working backwards a little bit. You're given an endpoint, 4 and -8. So I put my headers up here, x1, y1, and then you're given a midpoint. Normally we found the midpoint. That is the x and the y coordinate for the midpoint. So we're missing another endpoint. We are trying to find that other endpoint. 2 ways to do this, and I'm going to show you both. First, I have my midpoint formula right here. So x1, x2. We don't know the x2 value. We don't know the y2 value. But what I do want to point out is the x1, y1, x2, y2. Those are endpoint values to figure out your midpoint. So to use your midpoint formula and solve this all algebraically, this is what you would do. You'd take this fraction and set it equal to what your midpoint is. In this case, the x value is 10. So that's basically what I did. I substitute 4 in for x1. The x2 is unknown. I set it equal to 10, which is our midpoint answer. Same thing for y. Set it equal to -6. That's your midpoint value is -6. So I substitute -8 in the top. Basically what you do here is you'd solve it algebraically. It's solving equations. So in both equations, and actually you just break it down, you can work one equation at a time. So you need to get x2 alone. In order to do that, you'd multiply both sides by 2. Coincidentally, over here, y squared, in order to get it alone, you'd have to multiply by 2 to both sides. So I multiplied both sides by 2. I would wind up with, your 2's would cancel out here, you'd wind up with 4 plus x squared equals 20. And your y's would be negative 8 plus y squared equals negative 12. To solve for x squared over here, we'd subtract 4 from both sides, and you'd find out that your endpoint is, for x, is 16. Over here, we'd add 8 to both sides, and your y endpoint is negative 4. So your endpoint is 16, negative 4. That's solving algebraically. Another way to solve is actually to graph it. It would look something similar like this. You have an endpoint, you have a midpoint. We need to figure out that other endpoint. So that midpoint is between the two endpoints. So on your coordinate plane, it would look something like this. If you plotted 4, negative 8, which would be somewhere down here respectively, that's an endpoint. Over 10, down 6, there's your midpoint. So theoretically, your other endpoint would have to be up here because your midpoint is between the two endpoints. So here's another way to problem solve. Well, you moved over 4 units and you moved over 10 units. How do you go from 4 to 10? Well, you add 6. So in order, you'd gain 6 here. From here to there, you would also gain 6. So your y value would be, or sorry, your x value would be 16. Your y value, negative 8, well, we go from negative 8 to negative 6. So it's increasing by 2. So from negative 6, increased by 2, we should come up to a negative 4. So both ways, you could do it from a graph, or you could solve algebraically like we did above. Example 4 is the distance formula. You're going to find the distance of the line segment. So you're given two plots, and here is your distance formula. You have d equals the square root of x squared minus x1, or x2 minus x1 squared, plus y2 minus y1 squared, and this is all under your square root. So start off by putting your headers on, x1, y1, x2, y2, substitute into the correct spot in your distance formula. Your x2 value is 1, minus your x1 value 5, that is squared, plus your y2 value is negative 2, minus y1, which is 3, that is also squared. You wind up, after you do your computation, negative 4 squared plus negative 5 squared. Negative 4 squared is 16, negative 5 squared is 25, and you would get the square root of 41. Forgot up here, but in the directions we need to round to the nearest tenth. So if you find the square root of 41, you would come up with 6.4 units. That would be the distance of that line segment. Example 5, I'm going to go ahead, have you pause it here, work through example 5. Make sure you put those headers on, work through it. Maybe I'll help you get started on this first part here, but your distance formula, your x2 value is 3, and then it's, remember, it's minus, while your x1 value is negative 3, so you have minus minus right here. That's going to be turning into a big positive. So go ahead and take it over from there. All right, now that we're back, we should have substituted in negative 7 minus negative 2, that would be squared, giving us 6 squared and negative 5 squared, which would be 36 and 25, together giving us the square root of 61, and rounded to the nearest tenth would be 7.8 units. The last two examples are very similar to examples 4 and 5. The only difference here is that we're going to leave our answers in radical form, meaning that we are not going to have any decimals. We are going to leave it as a square root. The biggest thing is, if you do have a square root, to make sure that what's inside of your square root is simplified. So in this first example, again, you use your distance formula. We substitute 4 in for x2 minus 6 in for x1, square it, plus 5 in for y2, minus negative 2 in for x1, and we square it. Do your computation. Negative 2 squared plus 7 squared. We come up with 4 plus 49, which gives us the square root of 53, and that would be units, and the square root of 53 would not be able to be simplified. Example 7, I'm going to go ahead and have you pause the video again, work through example 7, and then report back in, and we'll see how we did. Following your substitution in your distance formula should look something similar to this. Minus minus, we'll turn this into a plus, so a positive 11. This will be a plus 2, so negative 4 plus 2 is negative 2. Again, squared both of them. We wind up with 121 plus 4, which gives us the square root of 125, which can be simplified, and it would be simplified into 5 times 5 times 5. With this, we're able to move out a pair of 5s, which we would wind up for our answer as 5 square root 5 units. This concludes lesson 63, 10-5, midpoint and distant formulas.